Exam style question, we're going to have a look at using internal resistance and calculations of current, voltage, etc. So I've given a few helping points so that you can have a go at the questions if you like to have a go at them first, but I'll go through them. So first of all, it's giving you an EMF of 9 volts. The EMF is the total voltage that's supplied by the battery to all the components in the circuit. So that's this component plus the combination of these two components. Now the EMF, we can say it's the terminal PD. So I'm just going to write that out quickly. Plus what we call the lost volts. So let's go through the difference of what these are. Terminal voltage or terminal PD is the PD of everything except what flows through the internal resistance. So it's the voltage of all of this plus the voltage of this. Whereas lost volts is the voltage that's wasted because the resistance here has internal resistance. Sorry, I meant the battery has internal resistance. And current has to flow through this to flow through the rest of the circuit. Now let's have a go at A part I. Calculate the PD between points A and B. Well, it's given us the resistances of the two resistors, and because they're in parallel, you can find the total resistance in this junction by using this formula. So let's do that. 1 over the total resistance is 1 over the first resistor that's in parallel, 2, plus 1 over the second resistor. 1 over 2 plus 1 over 2 is just 2 over 2, which is just 1. And then you do the reciprocal of both sides, but the reciprocal of 1 is just 1. So we have that the total resistance in this parallel combination is 1 ohm. And then also because it's given the current through the battery, we now know the resistance in the whole junction and we know the current that flows into this whole junction. So we can find the voltage using current times resistance. So it's just 1 multiplied by 1. So that would just be 1 volt. Great. Let's move on to part 2. So I mentioned the EMF is the terminal voltage, which is the voltage of everything except the internal resistance. So the voltage of everything here, plus the lost volts, which is the voltage that's wasted due to the internal resistance of the battery. So let's use that. We know the EMF is 9 volts. By the way, you always want to use this equation whenever it asks for the internal resistance. The terminal voltage is the voltage across this whole junction here, which we found in part I is 1 volt. But we also have to add onto it the voltage that's wasted due to this resistor here. Well, because 1 amp still flows through this resistor, because this is in series with the whole circuit, so it shares the same current as the whole circuit, we can say that the voltage flowing through this component is the current of 1 multiplied by the resistance of 6, so that's 6 volts. 6 plus 1 is 7 volts, and that's the total voltage, which is the terminal, so terminal voltage. So we can replace capital V with that, plus the current through the battery, which is 1, multiplied by the internal resistance, which we're looking for. So now we have an equation that we can solve for R. So 9 is equal to 7 plus R. We can get rid of the 1. Take away 7 from both sides, and we get R is equal to 2. So that's 2 ohms. Great, let's move on to part 3. So in part 3, it's asking for the power transformed by the battery, and it's giving you a time. Oh, sorry, for the energy transformed. So we first need the power in the battery. I wrote here power is current multiplied by voltage. We know that the current flowing through the battery is 1 amp. We also know, let's write that here, that the voltage in the battery is just the EMF, it's 9 volts. Using that and IV, we can find that the power is the current of 1 times the voltage of 9, so that's 9 watts. We then take that power and we multiply it by the time, but you have to convert the time in seconds actually. So we take the time of 5 and multiply by 60 to come into seconds. And all that multiplies to 2700. Hopefully. Yeah, it does. Perfect. Lastly, we're looking at the percentage of energy that's dissipated in the battery. So dissipated is another word for wasted, and the energy that's wasted is due to the internal resistance. So if we find the energy that's taken up due to the internal resistance and put that over the total energy in the battery that we found before and times it by 100, that'll give you the percentage that's dissipated. So let's do that. Let's find the energy that's wasted. We first need the power through the internal resistance, which is the current through the internal resistance, times the voltage that's wasted due to the internal resistance. Now looking back at this equation, we know that EMF is 9, terminal voltage is 7, so lost volts, the amount of voltage that's wasted due to the internal resistance, is 2. So that's our voltage that we use here. And then the time in seconds, so that's 5 multiplied by 60. That will get you to a value of 600. We then take that wasted energy and put it over the total energy transformed by the battery, which we found was 2700. That will give you a fraction. You then multiply it by 100 to turn it into a percentage. So for this one, I will need a calculator. Actually, I don't. I'm trying doing this in my head. It will be 22%. On your calculator, you'll say 22.222%, but yeah, 22% is fine. Hopefully that makes sense, and please let me know if you have any questions in the comments. Otherwise, thanks for watching. Please like and comment on the video and subscribe as well. I'll post a new video every single day. If you want any specific video, just let me know in the comments as well. Thanks for watching.